Infrastructure. It's hard to imagine a dollar word for something so critically important to the daily functioning of every economy, the health and safety of more than 7 billion people, and stuff that quite literally touches our everyday lives. Why fixate on the word? Well, perhaps it's the lack of enthusiasm and imagination that the word often conjures that is at least in part responsible for a sustained worldwide lack of spending to maintain and modernize the world's vast array of infrastructure. A 2016 UN report entitled Bridging Global Infrastructure Gaps found that while the world invests some $2.5 trillion a year in transportation, power, water, and telecom systems, this investment is far short of the 3.8% of global GDP, or an average of $3.3 trillion a year between 2016 and 2030 in economic infrastructure needed just to support expected rates of growth. In other words, just to continue to keep the lights on and the economy moving, world economies together must spend 33 trillion US dollars, or equivalent to 50 trillion New Zealand dollars, over the next decade. This is a massive investment, and this is something that needs to take place with careful consideration towards growing crises like climate change, massive rural to urban migration, and severe economic disparities and poverty. This is quite a heavy load for such an innocuous term like infrastructure to carry. It's the planners in every country, in every city, in every town across the globe that will help shape the way we live in the next several decades and beyond. Welcome to Sustainable Infrastructure Planning.
Today, the government is announcing, as you've seen, the details of the major projects that make up the New Zealand Upgrade Program, the most significant investment in public infrastructure in a generation, designed to future-proof and grow our economy. New Zealand has had underinvestment in the core public facilities we all use, and that has happened for too long. Our schools and hospitals have been run down, or they don't have the full range of facilities they should, be it a new school library or a neonatal unit. There is unmet need across the country, and this program aims to fix that.
Infrastructure. It's not just the pipes in the ground, or the wires overhead, or the streets in between. Everyone likely has their own ideas about what constitutes infrastructure and a preconceived notion about how it should be approached in a planning context. So that we all start off on the right foot, let's begin with a formal definition. The Infrastructure Planning Handbook, one of the definitive textbooks on infrastructure planning, defines it as follows. The term infrastructure is applied to facilities that actually require substantial capital investments, provide public services, or solve problems perceived to be the public's responsibility, and are planned, designed, constructed, and operated by or under the auspices of government agencies. Let's unpack that pretty dense definition a little bit. An important phrase is the definition public services. Infrastructure is developed or maintained by public agencies. For example, there are public-private partnerships and there are private organizations that have fully developed infrastructure on their own. The vast majority of infrastructure is for public use or good and is developed, maintained, and operated by public agencies. Development of infrastructure takes place over a fairly long planning horizon, with larger projects taking years or even decades to complete. No matter the size or timeline an agency is facing, projects generally follow a specific set of planning phases. As this definition alludes to, the phases include planning, design, construction, and operation. This course will cover each of these phases as we walk through the infrastructure development process. Within the planning phase is multiple steps which include feasibility analysis and cost-benefit analysis to determine whether a project will meet a desired set of needs and if the benefits of that project will be equal to or greater than the costs. We will get a lot more into BCA, benefit cost analysis, later this semester. BCA gets a bit more complicated for the public sector, especially for infrastructure projects, compared to private sector analysis, as the public sector has to consider equitable distribution of public goods and will include, in some cases, consumer surplus in addition to revenue within the benefits category. But more on that later. The design phase, while its own process, also has feedback to the planning stage. Preliminary designs are used in the planning phase to determine the overall feasibility of the project and to estimate costs associated with those preliminary designs. Once a project advances to the actual design phase is when the details about the engineering, the architecture, and the overall plan for how the project will look and how it will operate are solidified. The design phase proceeds only after the project gets statutory and financial approval. This is also the phase where civil engineers begin to get involved in the project. It's pretty clear what happens in the construction phase, just by the name alone. There are a number of issues that can crop up around construction that also have to be dealt with in this phase. This can include things like dealing with earthquake potential, erosion, noise abatement, which can be a very important project depending on where it's being constructed and the surrounding land uses. Even traffic control, especially if work is being done on a highly utilized corridor or a bridge or something like that. The final phase is operation. This can require minimal effort, which is simply maintaining a road or more involved process, for instance, like keeping sewage treatment plants running. It also may involve private parties. For example, a private company that operates a toll road or maintains vegetation along a road reserve. Let's round out our definition of infrastructure with one more take on its meaning. Another definition from the 2011 National Infrastructure Plan. Infrastructure is the fixed, long-lived structures that facilitate the production of goods and services and underpin many aspects of quality of life. So, infrastructure should clearly be well built and long-standing, since the project takes so many resources and are aimed at improving the long-term public good. Of course, that's not always the case with infrastructure in both New Zealand and many other places around the world.
There's concerns tonight it could take years to rebuild a 400-metre stretch of road between Whanganui and Ratahi after a slip caused it to completely collapse in both directions. Now, if you're watching, the pictures of the slip are quite extraordinary and dramatic. They're similar to a broken road at the epicentre of an earthquake. The paraparas on State Highway 4 are now closed from south of Ratahi to the Field Tracks intersection for the foreseeable future. Now, that means drivers will face detours of up to an hour to get to Ratahi from Whanganui and the reverse.
Although highlighted in that last clip, natural environmental effects are not the only things that can cut short the life of infrastructure. Failing to plan for adequate growth or demand of the infrastructure can also significantly reduce its useful life. This is the really big challenge for planners. It's not a straightforward science. Estimating demand is based on forecasts that can be many years into the future. A lot can and does change between the year of the forecast and when the infrastructure is actually put into use. The last aspect of the infrastructure definition from the National Infrastructure Plan is a reminder about how ubiquitous and in some cases general the term infrastructure really is. Infrastructure refers to physical networks, principally transport, water, energy, and communications. But this definition misses the critical other type of infrastructure, and that is social infrastructure. We'll talk a little bit more about this in the next module.
It's a modern plan for our future. It asks not just what our infrastructure needs are today, but how we can future-proof them for tomorrow. How we can deliver traditional projects like roads and buildings in a way that reduces our emissions, that gives transport options to commuters, and that tackle climate change.